Hello, we are now on the subject spherical trigonometry. In this lecture, I will discuss to you some of the properties of a spherical triangle, as well as we will determine some missing arcs and angles, as well as the areas of a spherical triangle. So let's start. Spherical trigonometry is a branch of trigonometry that concerns with triangles extracted from the surface of the sphere. Spherical triangle is that part of the surface of a sphere that is bounded by three arcs of a great circle. And the bounding arcs are called the sides of a spherical triangle. This one, C to B, B to A, and A to C. Okay. So, the points of intersection of these arcs are called the vertices, point A, point B, and point C. The angle formed by two intersecting arcs is called the spherical angle. So, in a plane triangle, we call that as an interior angle. Here in spherical triangle, okay, that angle formed by two intersecting arcs are called the spherical angle. So, we name that angle A, angle B, and angle C. So, let's take a look at some properties of spherical triangle. There are properties in plane trigonometry or in plane triangle that we can use here in a spherical triangle, but there are some properties that we cannot adapt. One of which is the sides and interior angles of a spherical triangle are both expressed in angles. So, unlike in plane trigonometry, the sides are expressed in the unit of distance. Here, sides and interior angles are expressed in angles. Number two is if two sides are equal, the angles opposite are equal and conversely. So, same principle with plane trigonometry. If we have a triangle that has two equal sides, the angles opposite to that sides, okay, to these sides, are also equal. Same way with spherical triangle. Two sides are unequal, the angles opposite are unequal, and the greater side is opposite the greater angle, and conversely. So, same principle then sa plane trigonometry. If one angle is greater than the other, or if one side is greater than the other, the angles opposite to that side are greater than to the other. So, ganun din sa spherical triangle. The sum of any two sides is greater than the third side. So, we're talking about here with sides of a spherical triangle. When you add the two sides of a spherical triangle should be greater than the other side. So, any two sides of the spherical triangle should be greater than the other side. Also, when you add the three sides of a spherical triangle, it should be less than 360 degrees. Therefore, our sum of sides of a spherical triangle should be within the values of 0 degrees to 360 degrees. Okay? The sum of any two angles is less than 180 degrees plus the third angle. So we are now on the angles or the spherical angles of spherical triangle. So when you add the two interior angle of spherical triangle, it should be less than the sum of the third angle and 180 degrees. Okay? Then, the sum of the angles is greater than 180 and less than 540 degrees. So, dyan yung range ng sum of interior angles natin. Unlike in plane trigonometry where the sum of interior angles should be exactly 180 degrees, here in spherical trigonometry, it should be greater than 180 degrees and less than 540 degrees. Alright, spherical triangle is a spherical triangle having a right angle. And one solution to that is the Napier's rule. In Napier's rule, as you can see here in a spherical right triangle, where the right angle is angle C, we should draw a circle and divide it into 5 parts. Then write down the sides and the spherical angles in order, except the 90-degree angle or the right angle C. So, as you can see here, don't include angle C, but write down A, B, then next to side B is angle A, then side C, and angle B. So, in the Napier's rule, okay, the sides adjacent to the right angle, which is A and B, the values for these sides are retained. But for the angles and sides that are not adjacent to the right angle C, we should put a bar on those sides and angles. So, what do you mean by this bar? Okay, means that we should determine the complement value of that angle. Therefore, if I have an angle here for angle A of 50 degrees, let's say 50 degrees, it means that the value that I will put here in bar A is the complement value for this angle A. Therefore, 90 minus angle A, or 90 minus 50. Same here, if I have an angle for this side of 30 degrees, okay, I need to determine the complement of this side. Therefore, bar C is 90 minus side C, or 90 minus 30 degrees. Same here for bar B, 90 minus the given angle B. So, how do we use this figure in solving a right spherical triangle? So, according to Napier, the sine of any middle part is equal to the product of the tangents of the adjacent parts. This is also called as the sin-taad rule, where the sine of any middle part, so what are the middle parts here? So any of these sides and angles, we can use that as a middle part, is equal to the product of tangents. So tangents of adjacents to that middle part. So if I select A as the middle part, we will write down sine of A is equal to what? The product of the tangents of the adjacent parts. What are the adjacent parts? Bar B and angle B. Therefore, I can write down this solution as tangent of bar B times tangent of side B. Okay? If I selected bar A as the middle part, say let's use color green. If I selected bar A as the middle part and I use the sin-taad rule, we'll have sine of bar A is equals to the product of tangents of the adjacent parts. So this is adjacent, therefore tangent of bar C times tangent of B. So we can use any middle part here depending on the given values for the sides and angles that is more convenient for us to use. So it is up to us to what middle part we will choose. So, another solution is the sin-co-op rule, or the sine of any middle part is equals to the product of the cosines of the opposite parts. Let's say angle A, side A again is the middle part here. In sin co-op rule, the sine of that middle part is equals to the product of cosines of the opposite parts. So what are the parts opposite to this side? This one and this one. They are opposite. They are not adjacent to this side A. Therefore, I will just put a trigonometric function cosine to bar C and multiply that to cosine of bar A. Okay? So if I use B as the middle part, apply again sin co-op rule, the sine of B is equals to the product of parts opposite to this part, this middle part. So ang opposite dito, ito at yan. Therefore, these parts are opposite to B. Therefore, cosine of bar B times cosine bar C. Okay? So, that's it. We can now solve some problems in right spherical triangle. Solve this. Solve the following right spherical triangle, where angle C is 90 degrees, angle A is 50 degrees, 20 minutes, and C is 80 degrees, 30 minutes. So, let's draw the figure. Okay. So, this is the figure for this problem. We have an angle A of 50 degrees and 20 minutes and side C of 80 degrees, 30 minutes. C is opposite angle C, which is 90 degrees. Therefore, Napier's rule is applicable for this particular problem. According to Napier's rule, first draw a circle and divide it to 5 parts. In each part, it corresponds to the sides and angles of a right spherical triangle without including the right angle. So, make sure that we assign each part in proper order. We have side A, B, exclude angle C. Then we have A, C, and B. Then, the angles for the sides adjacent to that right angle, which is C, should be retained. Okay? So, the values of A and B, which is unknown, okay, is retained. Then, for the remaining angles and sides, okay, we will determine the complements for each sides and angles. So, based on the given, we have C and A. Okay. So, for bar C, the complement of C is 90 degrees minus 80 degrees, 30 minutes. For bar A, we have 90 degrees minus 50 degrees, 20 minutes. Bar B, sabi na bar B, 90 degrees minus B. Okay. So, subtract natin except bar B. So, using our calculators, we can compute the complement of side C, which is 9 degrees, 30 minutes. Then, for bar A, we have 39 degrees and 40 minutes. Now, we are using Napier's rule. So, we use either rule number 1 or rule number 2 or the syntad or sin co-op. So, using this rule, we should take a look first on the given angles. We already determined bar C and bar A. Again, referring to this circle, we will identify which solution is easier, either syntaad or syncol, depending on the required value. So here, we are required to determine the angle B and sides A and B. So, if we are going to use syntaad rule, for syntaad rule, the sine of any middle part should be equals to the product of the tangents of the adjacent sides to that part. So, for syntaad rule, we need three adjacent parts o tatlong magkakatabing parts. And the middle part is applied by the sine function. So, in order for us to determine an unknown for this operation, we need to have two parts that has a value and one unknown. So, here, basing on the figure, we have bar C and bar A as given. So, in syntaad rule, if I select a middle part, let's say this bar C, I need the tangents of its adjacent parts, which is bar B and bar A. Therefore, I can use that solution in order for us to determine the value of bar B, since bar C and bar A are given. So, using syntaad rule, we have a middle part of C and the product of tangents of adjacent parts, which is bar B and bar A. Okay, then substitute sine of bar C is 9 degrees and 30 minutes is equals to tangent of bar B, which is unknown, then tangent of bar A, which is 39 degrees and 40 minutes. Now, when we able to determine the value of bar B, the complement of that value is the angle itself, B. So, let's determine bar B. Divide both sides by tangent 39 degrees and 40 minutes. We will have an equation of sine 9 degrees 30 minutes to be divided by tangent of 39 degrees and 40 minutes. This equals to tangent bar B. Transpose tangent function, we will have arctangent of sine 9 degrees and 30 minutes to be divided by tangent of 39 degrees and 40 minutes is equals to the angle bar B, or the complement of angle B. So, compute using our calculators. Arctan is shift tangent sine of 9 degrees 30 to be divided by tangent of 39 degrees and 40 minutes. So make sure that your calculators are in radian mode. In degree. Okay, degree mode, sorry. So our angle is 11 degrees 15 minutes and 24.59 seconds. That's the answer for bar B, but that's not the angle for B because that's just the complement. Therefore, we have to subtract 90 degrees because angle B is equals to 90 minus bar B, or it is the complement of angle B. Therefore, 90 minus 11 degrees, 15 minutes, 24.59 seconds. So, we have here B is equals to 90 degrees minus answer. Okay, click here to express it in degrees, minutes, and seconds. 78 degrees, 44 minutes, and 35.41 seconds. That's the answer for the unknown interior angle B. Next. Other unknowns, we have sides A and B. So this one we have already determined, bar C. So what remains is sides A and B. If we are going to use sin taad rule again, given bar C and bar A, if I will choose bar A as the middle part, I need the two adjacent parts, which is B and bar C. Since bar C and bar A is given and B is unknown, so we have one unknown and two given. Therefore, we will be able to determine side B. So let's use again sin taad rule. Kaya lang dito ang ating middle part ay bar A, then the product of tangents of adjacent sides, adjacent parts, is B and C. Now, right again, the sign of a middle part, I choose bar A, then tangent. Tangent of B and tangent of bar C. So, unknown is B. I divide both sides by tangents of bar C. So we will have an equation of sine of bar A divided by tangent bar C is equals to tangent of side B. Then arctangent of sine bar A divided by tangent bar C is equals to B. Substitute the values. We have arctangent of sine bar A is 39 degrees and 40 minutes. So 39 degrees 40 minutes to be divided by a tangent of 9 degrees and 30 minutes. That's angle B. So compute arctangent of sine 39, 40, and tangent 9 degrees, 30 minutes. Okay. 75. In degrees, minutes, and seconds, we have 75 degrees, 18 minutes, and 35.53 seconds. That's your answer for side B using sin taad rule again. Since we have already a value for side B, okay, when we try to apply again sin taad rule, I need a middle part and two adjacent sides. So using this equation, this solution, I need one unknown for apart. So at least you have two parts of this circle that has a value and one unknown. So since we have already determined the value for side B, bar A, bar C, bar B, I can use A as the middle part, and the adjacent parts are, say, this one. If this is the middle part, these are the adjacent parts. So let's write the solution for Syntaad rule again. The sine of a middle part, which is A, is equals to the product of the tangents of adjacent. That's bar B and tangent B. So required is A, side A. So arcsine of tangent bar B and tangent B. That's the value for your angle. Substitute arcsine of tangent of bar B. We will use 11 degrees 15 minutes because that's the complement of angle B. 11 degrees 15 minutes and 24.59 seconds. Then multiplied by tangent of B, which is 75 degrees 18 minutes and 35.53 seconds. Compute using our calculators. Side A is arcsine tangent 11, 15, 24.59. Then tangent again of 75 degrees 18 minutes and 35.53. Close parenthesis. Okay, that's it. Arcsine. Side A is 49 degrees 23 minutes. Okay, 49 degrees 23 minutes and 41.85 seconds. So that's your answer for side A. So that's how you solve using Napier's rule. Here in this example, I used Syntaad rule in solving this right spherical triangle. Now let's solve the same problem using Syn-Coop rule. In Syn-Coop rule, it requires a middle part and two opposite parts. So let's make sure that the values that we are going to substitute in our equation should have one unknown only. So here we have given of bar C and bar A. Now, if I will choose A, side A as the middle part, the opposite parts are bar C and bar A. Since both are given, we can already determine A using the equation in the Napier's rule. So that's the most convenient solution, and the most convenient middle part to be chosen is side A. So solution, the sine of a middle part A is equals to the product of cosine bar C and cosine bar A. From that, A is arcsine transpose sine function. We will have cosine of bar C and cosine of bar A. So ganun lang sa Syn-Coop rule. think of the best possible way in solving the unknown that is most convenient to you. As you can see, selecting A as the middle part is the best solution. So, back here again, substitute cosine 9 degrees 30 minutes. Okay, sorry. Multiplied by cosine 39 degrees 40 minutes. That's it. Solution 4A. Compute arc sine of cosine 9 degrees 30 minutes times cosine again of 39 degrees 40 minutes. Okay, it's equals to 49 degrees 23 minutes and 41. Seconds, which is the same. Okay, same answer using Sintaad rule, right? So compared to the solution in our Sintaad solution, we have an answer of 49 degrees 23 minutes and 41.85 seconds. So konting diferensya lang, but the answer is acceptable. So let's continue using Sintaad, Sin-co-op rule again. Since we already have an answer for A, okay, let's answer that. So we will choose again a middle part and two opposite parts. So you have to have one unknown in your equation. So if I choose bar A as the middle part, these are the opposite parts. Therefore, I have two givens and one unknown. So I can solve bar B. For bar B, okay, solution using Sin-co-op rule again. Sine of bar A as the middle part is equals to the product of the cosines of opposite parts. Cosine of A, cosine of bar B. So, divide both sides by cosine A. We have sine bar A over cosine A equals to cosine B. Okay, so arc cosine of sine bar A over cosine A is equals to bar B. So, substitute bar A, arc cosine of sine bar A is 39 and 40. For side A, cosine here 49. 49 degrees 23 minutes and 41.87 seconds. Okay, that's your answer for bar B. Bar B therefore is arc cosine sine 39 40, then cosine 49 23 and 41.87 degrees, close parenthesis, equals to 11 degrees 15 minutes and 24.58 seconds. To determine the value for angle B, this is the complement of angle B, therefore B is 90. minus bar B. 90 degrees minus 11 degrees, 15 minutes, 24.58 seconds. B is equals to, let's solve. 90 minus the answer is 78. 78 degrees, 44 minutes, and 35.42 seconds. So let's recall, if we have the same answer using syntad rule, let's see if it is in our calculator. This is the answer from the previous solution, 44, 35.41. So that's correct. The answer is acceptable. Last, side. Okay, we have part B. Side B. Using syn co-op rule again, if I choose B as the middle part, here are your opposite parts, bar B and bar C. So solution again, if we have B as the middle part, we have sine P is equals to product of cosines of bar B and cosine of bar C. So B is equals to arcsine of cosine bar B and cosine bar C. Substitute, we have cosine of bar B is 11 degrees. 11 degrees, 15 minutes, and 24.58 seconds. Cosine of bar C is 9 degrees, 30 minutes. So, compute. Arcsine of cosine 11, 15, 24.58, and cosine 9 degrees and 30 minutes. That's it. The answer is 75 degrees, 18 minutes. .54 seconds. So there's slight difference in decimals in the second value, but when you convert that into decimals, when you compare your answer in the syntad solution and syn co-op solution, they are almost the same. So that's it. That's how you solve a right spherical triangle. Next, since Napier's rule is limited only in solving right spherical triangle, we need other solutions in order for us to solve some problems in spherical triangle. So we use sine law and cosine law. For law of sines, we have the ratio of sines of sides to the sines of opposite angle to that side. So they are equal. So the difference with this solution in plane trigonometry on a plane triangle is that we apply sine function here on the side. So since our sides here are expressed in angles, so we apply sine function then dun sa numerator. So for the law of cosines, we have a separate solution for cosine law for sides. If if we have more given on the sides, and we also have a solution for law of cosines for interior angles. So if the given are more of interior angles. So here for the law of cosines for sides, so here are the solutions. We have a pattern here. Cosine of A is equals to cos of B and C plus sine B and C cosine angle A opposite to this side A. So pattern cos sin cos. Okay? For law of cosines for angles, we have cosine of angle A is equals to negative cosine angle B cosine C plus sine angle B sine angle C cosine side A. So we have a pattern here again, negative. For law of cosines for angles, we have a negative sign here for cos sin cos. So that's it. That's the formula for law of cosines and law of sines for spherical triangle. So actually, we can use this law of sines and law of cosines in a right spherical triangle. So for me, this is more recommended. These solutions, these formulas are more recommended rather than using the Napier's rule. So for the area of a spherical triangle, formula is pi r squared E over 180, where r is the radius of the sphere and E is the spherical axis. Spherical axis is computed by adding the three interior angles subtracted by 180 degrees. So let's solve an example here. Solve the following triangles and determine the area of the triangle if the radius is 40 meters. So let's solve. First, draw the figure. We have here a right spherical triangle. Say this is A, B, and C. Side A, side B, side C. Side A is 54 degrees. Then we have side B, 25 degrees and 101 degrees for angle A. So based on the given angles and sides, the most convenient solution that we can use is sine law, where since we have a given angle here and the opposite side A, okay, we can use side B and determine the opposite angle to that by using sine law, because in sine law we have sine of the side divided by sine of the opposite angle, which is this one. It's just equals to the ratio of the sine of side to the sine of opposite to that angle. Okay, sine B sine angle B. Okay, let's just make sure that we only have one given here, one unknown here. Given B, yes. A is given, angle A is given. Unknown is angle B. So let's cross multiply. We will have sine of A sine of B equals to sine B sine angle A. Divide both sides by sine of side A. We will have sine B sine A divided by sine side A. Transpose sine function, we have arc sine of B sine of angle A over sine of side A. Substitute the values here. We have B is equals to arc sine of angle B is 25 degrees, sine angle A is 101 degrees, to be divided by sine A, which is 54 degrees. Okay. Using our calculators, we can already solve angle B using sine law. Arc sine of sine 25 and sine 101. Make sure that you are in degrees mode. Sine 54. Okay. The answer is 30 degrees 50 minutes and 58.79, sorry, 79 seconds. That's the answer. Okay. Next, let's determine side C. Since we already have angle B here, okay, we can determine side C, or we can determine angle C. So we cannot use here sine law since we don't have a value for side C or angle C. So the best solution here is we use cosine law. So based on the solved solution here, we have angle B, angle A, unknown value for C, and we have side B and side A. So it's either we use the law of cosines of sides or the law of cosines of angles. So here I will use law of cosines of sides. Now I choose A as the side for the left hand side of our equation. So cosine A is equals to cos cos sin sin cos. So cosine of the other sides B and cosine of C plus sin B sine C and cosine opposite to this side is angle A. Okay. So based on the equation, let's verify first if we can determine an unknown. A is given, check. B given, C is unknown, given, unknown, and A is given. Therefore, we have one variable that is unknown. So therefore, we can compute this equation. So we can compute here side C. So substitute now. Cosine of 54 degrees equals to cosine of B, which is 25 degrees, cosine of C, plus sine of 25 degrees sine C times cosine angle A is 101 degrees. Now we cannot solve C by simply combining like terms isolating C because we use different trigonometric function for this term, cosine for C, and here sine C. We cannot also use any trigonometric identities in order for us to simplify this equation. So therefore we can only solve this using by our calculators. So make sure that your calculator has a function of shift and calculate. So here in our calculator, make sure that you have this calculate and or solve function. So means that if you input here the equation cosine 54 equals to cosine 25 cosine C plus sine 25 sine C cosine 101. The calculator will automatically calculate the variable C. So here, let's input cosine 54 is equals to, also show the equals 25 and cosine C. So in solving for the variable C, here in our calculator, we will use the letter X in solving for the variable. So always use X in solving the unknown in an equation. Then plus sine 25, then sine X, cosine 101. Then shift calculate. So the calculator will ask you an initial value. So our calculator will undergo here what you call iteration. Means that if you have an initial value, the nearest possible answer will be referred to the initial value that you have input here in your calculator. So the nearest possible answer will be derived from your initial value. So I think based on our figure of our uh, spherical triangle, I think our angle will not exceed 180 degrees because I think that's not realistic, or it will not be negative. So it is positive value from 0 to 180 degrees, I think. So we will input here an initial value, any value. But I think I will assume an angle here, a possible answer here. Let's say I think it's 90 degrees. But of course, our calculator will solve the variable here in our, or the correct answer here. So if I put here 90, then equals, the answer will be 44.67497. Okay? Because if I input here 180 degrees, okay, let me just show you. It will show you a different answer. And 764 degrees is, I think, not realistic when you draw it here. It is more than 360 degrees. So that's not the correct answer. So let's say 20. It will always show you the correct answer, which is 44.6749. But if I input here 0, let's say 0, okay, 305. So that's not realistic. So again, type the equation, then shift solve or shift calculate, then input an initial value, let's say 50, then it will show you the correct answer, 44.6749715 degrees. Now, how to translate that into degrees, minutes, and seconds? So just AC, then answer equals to, or alpha x, okay, because it will automatically save on the x letter. That's it. So alpha x then equals 44. So just click answer, then click this button. 44 degrees, 40 minutes, and 29.9 seconds. So C therefore is 44 degrees, 40 minutes, and 29.9 seconds. That's your answer for side C. To solve angle C, we will just use sine law. Using sine law, okay, let's use again sine of side C over sine angle C is equals to sine side A over sine angle A. Cross multiply, we will have sine C times sine angle A is equals to sine A times sine angle C. Then divide both sides by sine of A. We will have sine side C sine angle A over sine A equals to sine C. Transpose sine function, we will have arc sine of sine C sine angle A over sine side A equals to C. Substitute, okay, just like here in our example here, arc sine of sine of 44 degrees 40 minutes and 29.9 seconds sine angle A. Angle A is 101 degrees to be divided by sine of A is 54 degrees. It's equals to C, capital C. Okay. Solve. Arc sine of sine 44, 40, 29.9, then sine 101 over sine 54. Solve. 58.54966 or 58 degrees 32 minutes and 58.78 seconds. That's your answer for angle C. To compute the area, okay, compute the area. Formula for the area is equals to pi r squared E over 180, where E is the spherical excess. Excess is the sum of the three interior angles of the spherical triangle minus 180 degrees. So just copy the interior angles. B 30 degrees 50 minutes and 58.79 seconds plus 58 degrees 32 minutes and 58.78 seconds minus 180 degrees. Spherical excess is compute 101 30 50 58.79 and added by 58 32 and 58.78. okay, minus 180 degrees is equals to 10 degrees 23 minutes and 57.57 seconds. Now substitute here. We have 40 meters 4 radius square equals to 10 degrees, 23 minutes, and 57.57 seconds to be divided by 180. Okay. 180 degrees is equals to, solve by 40 square times 10 degrees, 23, 57.57 over 180. Okay, we have 290. So it's a unit of area. We can use decimal. 290.404 square meters. That's your answer for the area of the spherical triangle. So these are your answers. That ends our lecture for spherical trigonometry. Thank you for watching. God bless.